Okay, so these normalisation questions are coming from a different exam board. Even though we are CIE, these are still really good questions to answer. So pause the video, give us a go yourself first, and then we'll do a solution. So in this question it says that everything is fully normalised. State two properties that the relations in a fully normalised database must have. So it's basically saying two things that we should have in a fully normalised database. You haven't learnt about fully normalised. You've only gone up to third normal form. But even so, what you can mention would count towards the answer. So you can mention, for example, by all of these data structures, the way it's laid out with the fields and in these different tables, you're going to get data which is atomic. There's no repeating fields or attributes. If we look at the relationships between these fields and their primary keys, there's also no partial slash, we can also say no non-key dependencies. Slash transient. So if we look at this, title depends on book ID, author depends on the book ID, the publisher depends upon the book ID as well. So all of these aspects depend upon the book ID. Surname depends on the member, forename depends on the member, the house number depends on the member, the street name depends upon the member, the county depends upon the member, the postcode depends upon the member, date of birth depends upon the member, email address depends upon the member. You could argue that postcode, which is like a zip code, depends upon the county. Well, actually no, it depends upon all of these things, I guess. Yeah, I think everything's fine there. Returned depends upon all three of these keys. The member ID, the book ID, the loan date. The due back depends upon those aspects. Return doesn't depend upon due back. Email doesn't depend on date of birth. So the point being is there's no transient dependencies or non-key dependencies, no partial dependencies. Data is atomic, so it is definitely in at least third normal form. I'm going to change that to transitive rather than transient. My bad. Should say transitive rather than transient. Okay. Let's do another question. So we're using the same database structure, and the question is now saying the system requirements have changed. The library now needs to be able to stock more than one copy of the same book. Two different copies of the same book will have the same book ID. What can we do to our database design to ensure that to happen? So pause the video, give that a go yourself first. How can you incorporate these changes and ensure you've got a normalized database? Okay, so what we're going to do is we've got book ID, table book, which has book ID, title, author, and publisher. That stays the same. But I'm going to create a new table, and I'm going to call it, let's call it book version. And in book version, we're going to have version ID, and we're going to have book ID as our joint primary key. So we've got a relationship here. This is a foreign key. This is our primary key. We join them together. In here, this is our primary key. So we could have, let's say, imagine we've got a book ID 1. Let's do Titanic. Blah 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 blah. We can have version ID 1 Titanic. We can have version ID 2 Titanic. Then we can have version ID 1 Lion King. I can't think of any books I'm giving movies here. Lion King here. Version ID 3. So we create a new table. The relationship will be one book can have many versions. But we're not finished. What we're going to have to do, I'll move this down, is also change loan. So instead of loan taking the book ID, we're going to have take the version ID and the book ID. So that we know which version of the book we're hiring out or loaning out. So I would just have to put all of that in sentences. I'll most probably, for this question, draw it out like this. I'll then probably draw out this loan table, show the relationship and describe what's going on. One book ID can have many versions. I then talk about one loan, it's like one version of a book can be lent out many times. Okay, so we've got this question. Pause the video, give it a go yourself first, and then unpause. Okay, so these relations are in third normal form. What does this mean? Why is it important that relations in a relational database are in third normal form? So what does it mean to be in third normal form? Well, every attribute is fully dependent on the primary key. We can also say no atomic data. Sorry, data is atomic data. No partial dependencies. No non-key dependencies. Why is it important to have data in third normal form? Well, this is what you should have learned about relational databases. It's easier, so it eliminates update, insert, delete, anomalies like we saw in the video with the video game where I'll do an example right now. So imagine we've got a game, we've got my kill streaks. So it's kill streak ID 1, 2, 3, player ID 1, 1, 1, 1, player name Lev, number 4, let's say player ID 2, kill streak of 100, and we'll call this person Boris. Okay, if we were to remove Lev from the game, it would, well, let's imagine actually, let's say it's about, I was to clear my kill streaks. If I was to clear my kill streaks, it would also remove Lev from the game as well. If I was to remove all Lev's kill streaks, that would be a delete anomaly. That's a bad thing. This, remember, is not in third normal form. It's not in third normal form because I'm hoping you know that player name is dependent on player ID. Well, let's imagine that we've updated player name. So player name is, I've changed my username and I want to be called Levin. We do an update query. It hasn't updated everyone's, all my Levs. It's left this one by mistake. So that is an update anomaly. if we were to do this in third normal form, it's really simple, because we would have a table called player, we just change the player once and it's changed forever. But because we've got repeated data, higher chance of data issues with anomalies and data inconsistency. We also have duplicate data. So we want to reduce it by using third normal form. Pause the video, give these questions a go, A and B. Okay, so let's do A. What is meant by a field, and give an example based on what we've got above. So a field is an attribute or column in a table. So an example would be IE customer ID in table customer. An entity is basically anything that data can be stored about. So any item at all, i.e. house or rental or customer, i.e. an entity is the table. Foreign key, a field that is a primary key in its own table, but is now linking its own table to another table, i.e. Customer ID in table rental. And there we go. Foreign key, entity, field. Let's look at this question. Is this in third normal form? And then give a justification. Well, first name is reliant on customer ID, last name is reliant on customer ID, date of birth, well, customer ID, email. Email's not reliant on any of these, they're not reliant on each other, so this table, done. Bathrooms depending on the house, beds, design, house, towels, on the house, road, on the house number, on the house. Deposit paid, to do for rental, monthly cost to do with the rental, house ID to do with the rental, yeah. So it's in third normal form. Justification, well, all fields are fully dependent on the primary key and no other fields. Then you can give an example, i.e. we can say all fields in table customer are fully dependent on customer ID. We're done. I'll see if I can find another one. Okay, whoops-a-daisy. Let's bring that down, pause the video, give us a go first. Okay, so let's do this bit by bit. Remove any partial key dependencies. Well, we know that's turning it from one normal form to second normal form, first normal form to second. Remove any repeating groups of attributes. That's turning it from a messy and normalized database to one. Remove any non-key dependencies is second to third. Nice and simple. Okay, pause the video, give us a go yourself first. So primary key, we need to give an example of a primary key. That'll be easy. Let's just do student ID. The table name would be student. Yeah. Foreign key. Well, we can say test ID. And that'll be in student test. You could also say student ID in student test. An attribute is any field at all. So let's just do last name. And we'll do that from student. Is this in first, second, or third normal form? Well, yes, 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 yes. Target grade has nothing to do. Well, it depends if it looks like we're only doing one class only because of this. This beginning here says that the student is only doing one class. Where the class could be, it might be a tutor group or it might be like class like science. Some target grade like new stuff. Fine, that works because the target grade is related to the student, the class is related to the student. It's not. There's no link there because it's only one. There's no multiple different classes. The max marks is related to the test, not the topic. The topic is related to the test, not max marks. Mark of what the student gets is related to the test they took and the student ID. Yep. So, third normal form. Okay, let's do this bit by bit. So I would like for you to do question A. Why is this table not in first normal form? Pause the video, give it a go yourself first. Okay, so we have some issues. Table has repeated groups, i.e. non-atomic data, i.e. multiple values in one cell. We've then got, in fact, that'll probably be enough for this. Yeah, so we've got that. This says each salesperson has a unique first name, so these are our primary keys. Dumb, I know, but yeah, whatever. Okay, pause the video. See if you can do question 2. Read it very carefully. You will need this information as well from question 1, so let me just neaten this out for you, and let me just X off this. Pause the video, give it a go. Okay, so I'm hoping you're going to go yourself first. Let me show you the solution. I'm not actually going to do it myself. Actually, I will do for the first one. It's not many. So all we have to do is do Nick. So this is the table salesperson. So it's been put into, it's been normalized. So we've got Nick, we've got Sean, and we've got John, and we've got the shop. So we've got TX, PH, and we've got TX. For table sales products, which are the fields here, this is what we should have. So if I go up, Nick has 3 pieces of data. Sean has 2, so 2 records. John has 4, and each row is unique. So it's taking a bit of information from each one. And there we go. Let's move down. I'm going to bring in another question. A relationship between the 2 tables has been implemented. So let me bring our tables into this. And let me just neaten this up. In fact, whoa, easy. Let me zoom out. This isn't our table, my bad. There we go. So a relationship between these two tables have been implemented. Pause the video, give this question a go yourself. This one here. Okay, so what we want to do is we want to describe the relationship between these two tables. Well, we've got a few things we can say. Number one, we are using the primary key from table salesperson is now used as a primary key / foreign key in table sales product, creating, let me just go down, a link / relationship and that is what we've got. You can mention that it's going to be a one-to-many relationship. We can have one person called Nick who appears many times. So if you mention primary key from table salesperson, which is name, I should have put what the primary key was. Primary key first name is taken from here, is put into here, and it's acting as a primary key with product name. It creates a link. It's now it's also a foreign key when it creates that link, and it's a one-to-many relationship. Explain why the sales product table is not in third normal form. Pause the video, give that a go yourself first. Okay, that is easy because manufacturer has nothing to do with the primary keys, first name and product name. These are primary keys. It's actually linked, well, or neither does number of products. Actually, no, number of products does. So manufacturer is just linked to product name, but product name is joint. The primary key in this table are both of these. Product name by itself is linked to manufacturer, but manufacturer is not linked to both first name and product name, therefore it's not in first normal form. So a geeky way of saying it is the following. There is a non-key dependency where manufacturer is reliant on product name, and product name alone is not a primary key. The final question is write the table definitions to give the database in third normal form. So table definition is basically the name of the table and in brackets all the fields that you want in that table. So an example of that would be this. This is a table definition. But how would you do this for third normal form? So what do we need to do in order to create a third normal form database? Pause the video, give it a go yourself first. Okay, so salesperson doesn't change, but we still need to put it down. So we've got first name, and we've got shop. First name is the primary key, so I'm going to underline it. We're also going to have sales product still, where we're going to have first name, we're going to have product name, These are both primary keys. And we also could still have number of products. But we're not going to have anymore the manufacturer. We're going to have a new table called product. In table product, we're going to have product name. And we're going to have manufacturer. Product name is going to be a primary key here. And in here it's also the primary key, so let's do that. But it's also a foreign key. It links this. And first name is a foreign key here. You don't need to do the arrows that I've just done, I'm just emphasizing my point. That is this database in third normal form. So we've taken this up here, or this, shall we say, and we turn it into a third normal form database.